Hey everyone, welcome to the Gaurab Stick. In today's video, we are going to break down one of the most important concept in computer networking, that is the OSI model. If you are a student or developer or someone interested in cybersecurity and networking, understanding this model is absolutely essential. So, let's get started. Now, let us understand the OSI model with an example. Suppose a person A is sending an email to person B. So, at application layer, person A interacts with email application like Gmail, writes his email to send. At presentation layer, mail application prepares for data transmission like encrypting data and formatting it for transmission. At session layer, there is a connection established between the sender and receiver on the internet. At transport layer, email data is broken into smaller segments. It adds sequence number and error checking information to maintain the reliability of the information. At network layer, addressing of the packets is done in order to find the best route for transfer. At data link layer, data packets are encapsulated into frames, then MAC address is added for local devices, and then it checks for error using error detection. And at the last level, the physical layer, frames are transmitted in the form of electrical or optical signals over a physical network medium like Ethernet cable or Wi Fi. After the email reaches the receiver, that is person B, the process will reverse and decrypt the email content. At last, the email will be shown on person B email client. In this diagram, we can see the complete OSI model with all 7 layers arranged from top to bottom. At the top, we have the application layer, which interacts with the users, and the bottom, we have the physical layer where actual data transmission happens. This layer structure helps divide complex communication into simpler steps. At the very top of the OSI reference model stack of layers, we find the application layer. This layer is implemented by network applications which generate the data needs to be transmitted over the network. It acts as an interface between the users and the network, allowing users to access network services through applications such as web browser, email clients, and file transfer tools. This diagram shows the application layer. It represents how the user interact with the network through application like email or browsers. This is where the data is created before being sent to lower layers. The presentation layer is responsible for handling the format and representation of data. It receives data from the application layer and converts it into a form that can be understood by the receiving system. This layer ensures that data is presented in a consistent format regardless of the difference in system architecture. It also plays a crucial role in data security by performing encryption and decryption, ensuring that sensitive information remains protected during transmission. Additionally, it performs data compression to reduce the size of the data, making transmission more efficient. Protocol used in this layer include TLS and SSL, which are commonly used to secure transmission over the internet. Formats such as JPEG, MPEG, and GIF are also handled at this layer as a part of data encoding and decoding. In this diagram, the presentation layer is shown handling data formatting. This layer ensures that data is converted into a proper format and also handle encryption and compression before transmission. The session layer is responsible for establishing, managing, and terminating communication sessions between two devices. It ensures that a stable connection is maintained while data is being exchanged and properly closes the connection once communication is complete. This layer also provides synchronization, which helps in recovering data in case of interruption during transmission. In addition, it controls the dialogue between two systems, deciding whether communication will occur in half duplex or full duplex mode. The session layer also provides authentication and security features to ensure that only authorized device can establish communication. Protocols used in this layer include NetBIOS and PPTP. This diagram represents the session layer. It shows how a communication session is established between two devices, maintained during data transfer, and terminated after completion. It ensures smooth communication between systems. The transport layer is responsible for providing reliable data transfer between the source and destination. It takes data from the session layer and breaks it into smaller units called segments, making it easier to transmit over the network. This layer ensures that all segments are delivered correctly and in the proper order. If any segment is lost or corrupted during transmission, the transport layer is responsible for retransmitting it. It also provides acknowledgement to confirm successful delivery of data. Another important function is adding source and destination port numbers, which helps in identifying the correct application process on the receiving device. Protocols used in this layer include TCP, which provides reliable communication, and UDP, which provides faster but less reliable transmission. Other protocols like NetBIOS and PPTP may also operate at this layer. In this diagram, the transport layer is responsible for breaking data into smaller segments. It ensures reliable delivery by checking errors and reassembling data at the destination. The network layer is responsible for the transmission of data between devices located on different networks. It determines the best path for data to travel from the source to the destination, a process known as routing. This layer adds logical addressing information such as IP addresses to each data packets so that it can be correctly delivered. The data at this layer is referred to as packet. The network layer ensures that packets are forwarded efficiently through intermediate devices such as routers. Its main functions including routing and logical addressing, making it a critical layer for communication across multiple networks. This diagram shows the network layer. It is responsible for routing data from one device to another across different networks. It uses IP addresses and determines the best path for data transmission. The data link layer is responsible for ensuring reliable connection between two directly connected devices. It takes data from the network layer and organizes it into frames for transmission. This layer ensures that the data is transmitted without errors by performing error detection and correction. It also manages flow control to prevent data overload and ensures proper sequencing of frames. Another important function is physical addressing, where MAC addresses are used to identify devices on the same network. Additionally, it controls access to the shared communication medium, ensuring that multiple devices can communicate without conflicts. This diagram represents the data link layer. Here, data is converted into frames and transmitted between directly connected devices. It also ensures error detection and correction. The physical layer is the lowest layer of the OSI model and is responsible for the actual transmission of data over the physical medium. It converts digital data into signals such as electrical, optical, or radio signals and transmits them through cables or wireless channels. At the receiving end, it converts these signals back into binary data which can be processed by higher layers. These layers define the physical characteristics of the network, including cable, connectors, voltage levels, and transmission modes. Its main function including bit synchronization, bit rate control, defining physical topologies, and specifying transmission modes. This layer forms the foundation of the entire communication process. Finally, this diagram shows the physical layer. This is where actual data transmission takes place in the form of electrical signals, light signals, or radio waves. All communication ultimately happens through this layer. This diagram together show how data flows step by step through each layer from the users to the physical transmission and back again at the receiver side. This concludes our OSI model explanation. We covered all 7 layers from the application layer down to the physical layer. Each layer has a unique role. Together, they ensure efficient and accurate data transfer across networks. Understanding the OSI model is key for networking and cybersecurity. Thanks for watching. Like, share, and subscribe to the Gaurab Techs for more.